Okay, I'm going to give you your first test of the semester Friday over the contents of this particular packet. Now it says write a function rule for the table. So this, again, this is called the dependent variable, and this is called your independent variable. Now we always start with our dependent variable W equals, now where's your W start at? It starts at 9. Then from there, are you getting smaller? You're getting smaller, so you're going to be subtracting. Okay. And then I got to find out what it is I'm subtracting every single time through the table. So I go 9 minus 7.5. I got 1.5. Then I take 7.5, and I'll put a 1.5 there. Then I'll go 7.5 minus 6. I got 1.5. Then I go 6 minus 4.5, and that's 1.5. Okay, so I'm minusing 1.5 every time. I can see that. Now, after the 1.5, I need to put my independent variable m, because it's dependent on how much time you have, so you put m there. Then if you're just going by ones and not going by anything else, just going by ones, you can circle it, you have your answer. But if you're going by like fives or something, you have to underline this part, just this part, and put that number. But that's enough right there. Okay, tell me whether the function's linear or nonlinear. You start at your y's, because your x's go by 1, so those are kind of irrelevant. So look at your 20, so take 20 minus 17. You got 3. You got to get the same number every time. So I go 17 minus 14, 3. And 14 minus 11 is 3. So I made it all the way through. It's all 3, so that's linear. Okay, now the next one. Start with your highest number. Your highest number is a 6, okay? So I'm going to start with 6. 6 minus and then negative 5. That's 11. Now take negative 5 minus negative 4. You got this negative 1 there, so you got a different number, so now the pattern's broken, so it's non-linear. It can't be a linear pattern. Now cross out the graph here, you don't need it, okay? And also set this up, I'll have it set up on your test or any assignments you do. Domain equals, range equals, and then write this phrase please, continuous or discrete. There'll be a table here too. So when buying gas, customers pay $3.12 per gallon of gas. I have $40. Identify the domain and range of the situation. Tell if the function is continuous or discrete. So I'm actually going to do my table on this blue sheet of scratch paper. It's got to be kind of a big table. So x, y. And x is time, but I don't have time, but I know x can't be the dollars. So y has to be the dollars and x has to be the gallons. So if you buy 0 gallons, you don't have to pay any money. If you buy 1 gallon, you have to pay $3.12. If you buy 2 gallons, that's going to be 3.12 times 2. Okay, leave that on your calculator, 6.24. 3, I just click up and go replace 2 with 3. 936. Now, what's my limit? My limit's $40, so I put 40 down here. So this dollars cannot go over 40. Okay, then I start going 4, 1248, 5, 15.6, that put a 0, so it's 1560. 6, 1872. 7, 2184. Okay, we're still not even close to being over 40, so we can keep buying gas. Okay, 2496. 9 gallons is $28.08. Keep buying it. $31.20. Then I get to 11. 34.32. 37.34. That's over 40. We can't go past 40, so we're done. Okay? So the domain, it goes from 0 to 12, and the range goes from 0 to $37.34. Okay, now is it continuous or discrete? Okay, well, let's figure this out here. So let's put 2.5. If you're pumping gas, you can pump in 2.5 gallons, okay? So 2.5 makes perfect sense. So 2.5 is part of the graph, okay? So it would be continuous because decimals are included. Okay, tell whether the relation is a function. I actually want you to make something right here too. Just make that U. So vertical line got to be straight up and down. So right there, 1. That's more than 1, so I stop and it's not a function. Okay, now this whole thing, you don't have a discrete set of points like you do here. You have a continuous set of points. So just make a vertical line and just make a couple of them. Right there, you just cross it one time right there. Right here, you cross it one time right there. So both of them cross at just one point, so that's a function. Okay, I want to go to this one. Tell whether that's a function. So that's only 1 point. That's 1 point. 1 point. 1 point. 1 point. 1 point. I made it all the way to the end, so we have a function. Okay, now the next one, you're graphing the function. You have y equals negative 3x plus 7. Use your table. And you're going to insert negative 2, negative 1, 0, 1, 2. Now take your time when you do this, okay? So I make kind of a little wall there because y is equal to negative 3 times whatever x is plus 7. So these are the numbers I'm going to substitute for the x. So I have negative 3 times negative 2 replaces the x, and then plus 7. You got 13. Now put your negative 1 in. Negative 3 times negative 1 plus 7 gives you 10. Negative 3 times 0 plus 7 gives me 7. Negative 3 times 1 plus 7 is 4. Negative 3 times 2 plus 7 is 1. Okay. Now, the x's go by 1, so this way you got positive 1, positive 2, positive 3, positive 4, positive 5, positive 6, positive 7, positive 8, positive 9. You have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, and negative 9. Now look at your y's. You go past the 9, okay? So you got to go by 2's on both the positives and the negatives. Even though you don't have any negatives, you still have to, if you're going by 2's this way, you have to go by 2's this way. So positive 2, positive 4, positive 6, positive 8, positive 10, positive 12, positive 14, plus 16, plus 18. Now you got to go by 2's this way too. Negative 2, minus 4, minus 6, minus 8, minus 10, minus 12, minus 14, minus 16, minus 18. Okay? So this is my X, this is my Y. So -2 and plus 13. So I go to -2 on X and plus 13's up here between the 12 and the 14. -1 and plus 10. Okay, if it doesn't have a sign, it's a plus. So I go to -1 on the X and plus 10 is right here. 0, 7, 0, and plus 7. So 0 just stays, and then plus 7's up here between the plus 6 and the plus 8. Plus 1, plus 4. Now I go to plus 1 on X, and then plus 4 on Y is right here. Then plus 2, plus 1. So plus 2 on the X is here. Plus 1 would be between halfway up to the 2. Okay, and those lines line up perfectly. So you take your ruler, just that's it. All right, now the last page. Identify the domain range of the relation, then tell if the relation's a function. So that's x, y, x, y, x, y, x, y, x, y. You're basically doing this, but you don't have a graph. Okay, so the domain are your x's, so you have 4, 1, 0, -2, 3. The range are my y's, so 2, 2, 1, 2, and 3. Now look at your domain. Okay, so the domain has no repeats. Every number's there only one time. So we have a function. Okay, next one, domain and range. So my domain are 0, 1, -1, 0, 2. And the range 2, -1, 4, -3, 1. Now you look at your domain, it's all you look at. You have a repeated number here, 0. So domain has a repeat, and that repeat is 0, so then it's not a function. Okay, that's the answer, not a function. Domain has a repeat, that repeat is 0, you got 2 of those, so not a function. Okay, last one, the total weight of a tractor trailer that carries its weight W of 337,000 pounds plus the weight of a car C, which is 4,200 pounds. Write a function rule for the situation. So the weight is my independent variable, or my dependent variable. My dependent goes all by itself. So we start at 37,000, and then it says plus, so it'd be plus the weight per car. Well, a car is 4,200 pounds, but I have to put the independent variable after it. That has to be multiplied by my independent variable, which is C, because it's every car I put on there.